Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox. And in this exercise, I'm titling it Peak Flow Rate Calculation. So we're going to be using the rational method calculator to determine the peak flow rate. And then on the screen here is the data. Specifically, what we're trying to find is the peak flow rate, Q sub P. And we're given this data right here, the return period of 50 years, time of concentration in minutes, the location, as well as a table here for our land use data. All right, let's go ahead and get started. We are looking at the hydraulic toolbox now. I have a project set up and another calculation. So let's add a rational method calculator. Go up to calculators and then click on new rational method analysis. I can also add one just by going right click and new rational method analysis, as well as clicking on this button right here, new rational method analysis from the tools toolbar, or the calculators toolbar. All right, so anyway, double click to open up the calculator. And what you're seeing here are the input variables at the top, and the flow rate, peak flow rate, which is what will be calculated, is down here at the bottom, grayed out. The three parameters required is the runoff coefficient, C, the area, A, and then the rainfall intensity, I. So I'm using US customary units for this example. So that's what you're seeing, acres and inches per hour. But if you had a different unit system, you can go ahead and switch that using this drop down by going up to the units menu and selecting the unit that you want. All right, let's go back to the rational method calculator now. What we're going to do is first tackle the runoff coefficient and the area at the same time. After that, we'll come back and calculate the rainfall intensity. And then with those three terms, we'll be able to calculate the peak flow rate. Okay, so let's leave that right there. I'm going to go back to my original table. This land use table here has the areas and the runoff coefficients already. In fact, it's already calculated the total area for us, but it hasn't created the total runoff coefficient, which you may consider sort of like a weighted average based on the area. It is sort of a composite runoff coefficient for this entire area that has a mix of different land uses. Now, I got this table right here from the Hydraulic Engineering Circular Document number 22, 4th edition. I'm on page 25, and this is example 4.1. So they give a couple examples, and that's the end of their example. But this is just the start of my example. And they calculate this composite runoff coefficient C value by basically, like I said, weighted average based on the area. So what we're going to do is use the data from this table right here, which is what I had copied into my PowerPoint slide right here. And then I'm going to bring up Excel with the exact same data, and I need to copy the data over and then run the calculations. Okay, so the original table is down below here. Excel is up above. I'll say 5.4 acres, 1.6 acres, 18.6 acres, and 17.7 acres. I'm going to run a sum on those terms and just confirm that it is indeed 43.3 acres. Okay. Very cool. Now let's enter the runoff coefficient data. So 0.9, 0.15, 0.25, and 0.22. All right. Now the weighted average for runoff coefficient would be equal to, actually, I'm going to start this off by going round, because I'm going to round it to the nearest 3 decimal places. Now the actual sum product command is sum product, open parentheses. We'll go with runoff coefficient as the first array, comma, and then the area as the second array. And then I'm going to close parentheses, divide by the sum of the areas, which is right here, close parentheses, and then I need to go comma 3 for the number of digits, and the second parameter is the round function, and enter 0.315. All right. So we're just confirming the numbers of 43.3 and 0.315, which were the same numbers we saw here, 43.3, and then 0.315 is their answer for this second step of the example problem. This document, let me just go up to the top real quick, has all sorts of great stuff for urban drainage design. I've based a number of my lectures and examples off some of their problems, not just the rational method, but also grates and inlets types of problems as well. And this HEC 22 document is just one of a number of different PDF files that I've been using and have been referenced from the user's manual and provide more detail than the user's manual when going through and making these videos on the hydraulic toolbox. So very helpful. Like I said, I'll leave a link to this Urban Drainage Design HEC 22 document in the description. Okay, so let's close that up. Let's minimize that. Back to the calculator, we can now type in our composite runoff coefficient for the entire watershed is 0.315, and then the area in acres is 43.3. Okay. So as far as the data input goes, we're 2/3 done, but the rainfall intensity is a little bit more involved. So let's get started with that. Now, if you happen to know the rainfall intensity off the top of your head, you could just type it in 1 inch per hour, for instance, tab off, and then a flow rate of 14.0 CFS is your peak flow. If it is, say, 5 inches per hour, just type it in, tab off, and boom, there's your peak flow, 69.9 CFS. I'm going to delete that though, because I don't know what the rainfall intensity is. But what I do know is that the location here is Sandusky, Ohio. The return period is 50 year, and the time of concentration is 24 minutes. So with that information, I'm going to click on the compute button right here. The whole point of this interface is to calculate the intensity in inches per hour. For the intensity curve computation, you've got a few options here. I'm going to go with user supplied and then define the storm data myself. So for the recurrence year, I'm going to select 50 years. That was given to us. And now what I need to do for the location of Northern Ohio is provide the intensity for 5 minutes, 10 minutes, 15, 30, and 60-minute storm durations. To help me out with that, I've got a web page here. This is the NOAA Precipitation Frequency Data Server. I'll leave a link to this in the description as well. I'm going to click on Ohio. It's going to open up a new browser tab for me. And then I'm going to just drag the red X up here to Sandusky, let that recenter, and then click on the plus button over here in the bottom right corner a few times. Okay, maybe one more time. And once I get fairly close, I'm going to click this checkbox in the top right to show stations on the map. Okay, so a number of different weather stations have popped up, which are NOAA certified and have the sufficient data. I'm going to single left click here on Sandusky. Over to the right, it gives me the station information like the name, station name, site ID, lat long, and elevation. But if I scroll down, this is where I get the estimated precipitation depths, and this is in units of inches based on the recurrence interval. So we want 50 years at this column here, as well as the duration of the storm. Now keep in mind, this is in units of inches, so we're going to have to convert that to inches per hour. Luckily enough, I've got an Excel table ready to go for this very reason. And what we're looking at here is 5 minutes. Actually, let me move this over here. Okay, this first row here is 5 minutes, 10 minutes, 15 minutes. So I'm going to just type that in, 0.663 precipitation depth for a 5-minute storm, 50-year recurrence, 1.01, 1.24, 1.78, that's for 30 minutes, and then 2.34 inches for the 60-minute duration storm, 50-year recurrence interval. So now to calculate the intensities, I just need to multiply by the number of times that duration occurs in 1 hour. So for 60 minutes, that's trivial. It's just 60 minutes. For 30 minutes, at that same intensity, we would divide by 1/2 for 30 minutes. So if I go, I'll just say 1.78 and then divided by the fraction of 30 divided by 60, and then, okay, there it is, 3.56. So I should be able to copy and paste this formula for the other 3 durations, and there is our curve. So as the duration increases, the precipitation depth increases, but the intensity decreases. All right, so this column and this column are the 2 columns of data that I need to input into the interface here. So let's see, 50 years, that's good. Let me move that over. Okay, there we go. And 5-minute duration, the intensity will be 7.956. For 10-minute, that's 6.06, 4.96, 3.56, and 2.34. All right, so click OK. We can remove Excel. Now what we have in this plot right here is this green line. It's kind of hard to see, but this is our intensity duration frequency curve. It's the one that's highlighted up here for 50 years. So we can see all of the numbers we input from 5 minutes up to 60 minutes. Notice the other recurrence data has not been provided, so that's why we're not seeing any data in the table, and we're not seeing any other lines besides the 50-year return. As far as calculating the intensity, it still says 0 right here. What we have to do is provide a time of concentration. And if we know the time of concentration, which we do because our notes say it is 24 minutes, then we can just go ahead and type that in right here, specified time of concentration, 24 minutes. And when I tab off and then click on compute intensity, it gives me an intensity of 3.942 inches per hour. Now there's also an equation right here. So I could type in 24, add that to 4.065, raise that to the 0.6214 power, and then 31.3 divided by all of that should get me the same value or something close to 3.942. So this right here is basically the equation of the curve. 3.9414. Okay. I mean, off 1,000th. So that's cool that that checks out. So I'm going to use 3.942 inches per hour. In fact, I think it's automatically added to the rainfall intensity right up here. Let me just go ahead and click on done. Yes, it added it automatically. Well, it rounded it to the nearest hundredth of an inch per hour, but that's probably all right. And that gives us a total flow rate of 55.1. This is our peak flow rate based off of the runoff coefficient, the area, and of course the rainfall intensity. All right, well, that's it for this exercise. What we did was use the rational method calculator in the FHWA hydraulic toolbox to calculate the peak flow rate based on our input data.